our focus will be on the numerical measurements for group data. Okay, for group data. What is the meaning of group data here? Group data actually is referred to the data that have been categorized into classes based on the value. So usually is if the data are having the same value, we will group in one class. Okay. So the classes can be either grouped by using the single score or using the class interval. Okay. Single score means that one class has only one value. Okay. Class interval means one class can have a class range from the lower boundary to the upper boundary. Okay. So that is the meaning of group data. Like for instance, this is a sample of group data. Yeah? There are 90 data altogether. All this data already been grouped based on single value. Okay, so that means there are 25 houses. Okay, are grouped under first class. We call it first class, because these 25 houses have no aircon installation in their house. Okay, so we group these 25 houses under the first category, under the first class. Okay, second class is for those houses that have only one aircon installation in the house. Okay, so they'll be under the second class for these 30 houses and etc. So if the classes, okay, have only one value, then we call this as the single score frequency table. Okay. How about second type of group data? Okay, group data also can be classified into something like this. Okay, I have one example here. Okay, whereby the class will be having the value of class interval. That means a range of number. Okay, so for the first class, for this one, there are 10 workers. Okay, between 21 to 25 years old. So if you see, this is the first class, whereby the first class value can be ranged from 21 to 25. So we call this as the class interval. Okay, class interval. So both of these class interval frequency distribution and also the single score frequency distribution all are considered as group data. Yeah. So there are two types of group data that we can present. So you may ask, what is the reason we want to measure the descriptive statistics by using the group data? Okay, so we use group data when there are so many data we have. We have collected maybe more than 100 samples, and then in order to help us to do the analysis, so it's better for us to group all this data into different classes based on the value they have. Okay, so those data with similar value will group into one class. That is easy for us to do analysis later on, yeah, to interpret the characteristics of the collected samples. Okay, so that is one of the reasons, all right. But there are also some disadvantages of group data. Yeah? Group data actually, right? We assume that for group data, we assume that, right, the observed samples, all the samples that are grouped in one category, in the one class, will have the same value. Okay, so that means that for this, okay, for instance, just now, our ungroup data here. Okay, this one, if we want to categorize the sample into different groups or different classes, we have to assume, okay, this 10%, these workers, we have to use a common value, okay, to represent this class. Okay, so for this class, we have to use the middle point, to represent the age for these 10 people. So how to get the middle point? That is, we have to use 21 plus 26 divided by 2, which is 23.5. So for group data, for this case here, we have to assume these 10 workers, okay, have similar age, which is 23.5. But actually, it's not true. In fact, it's not true. Okay, but in order to simplify our analysis, okay, we have to assume all these 10 workers who are under the first class have similar age, which is 23.5 years old. Similarly, also for the last class, these 3 workers, we have to assume all of these 3 workers have similar age. What is the age? 53.5. but it's not logic, right? It's not really true, but in order to just like do some rough estimation, then this is one of the way that we can use. So in short, actually the ungrouped data is still better. Okay, ungrouped data is still able to reflect, okay, the real characteristics of your sample. Okay, ungrouped data is still the best, but sometimes we may not be able to get the ungrouped data. Okay, or in order to simplify our interpretation of the characteristic of the population, we just simply use the group data. Okay, but the ungrouped data is still the best. Okay, so let us try to use the group data, okay, to calculate the mean, mode, median, first quartile, third quartile, standard deviation, variance, and also some other measurements. All right, so I'd like to use 3 examples, 3 cases. So we'll start from example 1. So example 1, actually, okay, we have this data here. So this data represent the number of acorns in a house, in a residential area in KL. Okay, so we need to understand the table given first. We may find that actually there are five classes here, right? This column is called as the class column, based on the number of acorn unit available or installed in the house. All right. And then the second column is referred to the frequency column. So it's referred to number of houses, frequency column. Okay. So we need to understand first, interpret the table correctly. So that means in this residential area in KL, 25 houses, okay, have no acorn installation, okay, without acorn. And then 30 houses in that area, okay, in KL, have only 1 acorn. Each house has only 1 acorn installation. Okay, and among these 90 sample, okay, 16 houses have 2 acorn installation, okay? And then 14 houses have 3 acorns each house. Okay, and lastly, there are 5 houses whereby each house has 4 acorn installation. So we have to understand the meaning of this group data first, okay, before we do any calculation. So far so good? Okay, so we'll start from the mean value first. Okay, because this is group data, and then the frequency distribution is presented by using the single score value, single score. So it's still group data, right? Group data. Okay, so let us try to calculate the mean value. Okay, because this is group data, so the formula to calculate the mean value is equal to total of frequency multiply the score for each class. Okay, and then you sum up, divided by total frequency. Okay, so bear in mind, this is the formula for mean value for group data. All right, this is different from the ungrouped data. Remember, the ungrouped data, the formula is not like this, right? When we calculate the mean value for ungrouped data, the formula is not this one. This is for group. Can you recall what is the formula to calculate the mean value for the ungrouped data? Anybody? Okay, I'll show you the difference. For ungrouped, last week that we studied, the formula is total X divided by number of sample available. This mean formula is for ungrouped data, right? For group data, because we already have the frequency value, so we need to take into consideration of the frequency value. So this is for group, this is for ungrouped. Okay, so don't confuse. Then how to use this formula now to calculate the mean for group data? Okay, so that means that we need to get ready 2 columns. Okay, we need to have F column and also the Fx column. Fx means F multiplied X column. Okay. So the blue column is the class column, which is X. We already have, right? It's already available from the question just now. The frequency column also already given in the question just now. F already have, all right? So now the problem is we don't have the Fx value, the total Fx value we don't have. So we need to build extra column by ourselves. We need to build, okay? So we can put Fx column on the right-hand side of F. Okay, so for the first class, what is the fx value? Fx value is equal to 25 multiply these are 0, right? Multiply 0, so it's equal to 0. Okay. So 25 is from here. This 0 is from here, from this column. Okay. How about second class? Second class also the same. We use 30 multiply 1. So you get 30. Okay. How about the third class? Third class is the f value is 16. So 16. Okay. Multiply the x value is 2. You get 32. So continue the same process. All right, for the fourth and also the fifth class. Then what is the next step? Next step is you need to sum up the total fx value for these 5 classes. 0 plus 30 plus 32 plus 42 plus 20, you get 124. So far, okay? This number? Okay. So this number you can substitute to the numerator of the formula. Yeah? Substitute this number. So we can substitute the number to the formula. Okay. To here. Okay. Then how about the denominator 90? How to get this value? Okay, this is the total f. Okay, so that is the sum of f column. So how to get 90? That is 25 plus 30 plus 16, 14, and 5. You get 90. Yeah? So substitute this 90 into the denominator. Oh. Yeah, into here. Okay, 90. So far, so good. Okay, then we simplify this expression. 124 divided by 90. So your answer is a continuous number, right? So if continuous number, usually we can just round the answer to 2 decimal places. Okay, round to 2 decimal places is 1.38 units. So how are you going to explain or evaluate or interpret the value of mean in this case? So you can say, on average, each house in the residential area in KL has 1.38 units of aircon installation. Okay. So in short, in order to calculate the mean value for grouped data, you need to get ready the F column and also the FX column. Get ready the F and FX column. I stop for a while. Any question on this? If you want to do it fast, you can copy this table. Okay, this is a shortcut. You can also check your answer, right? Okay, I use Excel. Okay, I use Excel. However, you can check your answer also. Okay, because sometimes you have a lot of these big numbers. So it's better for us to also to check your answer one more time. Okay, okay. Let's say this one I delete. Okay. So if you want to use Excel to calculate the mean value also manually, and this is called as manually method, also can. All right. So I try to bold it. Okay. So let's say we copy the group data from the question. Okay. So now is if in order to calculate the mean value, we need to get ready the F and also the FX column. Okay. F and FX column. So F value already given to us. So we just need to get the FX. So for the first class, the Fx is equal to 25 multiply 10. Okay, multiply. So I use this symbol, multiply 0. So it's B2 multiply with A2. Then press enter to confirm. Second class also the same. Press equal button. Okay, select 30, multiply 1, right? Press enter. Okay, so since the remaining cell also using about the same formula, that is using B cell multiply with the A cell, then if I really want to save my time, I can do in this way. Okay, since this figure already been formulated, okay, how can I do is I can just simply copy the formula for the remaining rows, like for 4, 5, and 6. So how to do so? Okay, you can select either C2 or C3, either one. Okay, let's say I select C3 or maybe C2. C2. Okay, so now I want to copy the same formula for the remaining rows, 3, 4, 5. How to do so? Okay, what can you do is you move your mouse cursor to the bottom right hand side of cell C2 until you can see a black cross sign. Can you see this? A black cross sign here. Okay, then you left click the mouse, left click, don't release, right? Left click the mouse and drag your mouse until cell C6, and then you release the mouse. Okay, so the Excel is able to help you to calculate the value for the remaining cells. Okay, so these are the values for fx. Okay, so if you want to calculate the total f and total fx, how? Okay, let's say we want to get the total f value for column B. Okay, so you can use the formula of sum, S-U-M, sum. Okay, select this. Right, you can double click, left click at this function 2 times until you see an open bracket. Okay, then you choose, you highlight B2 until B6. Then release your mouse, and then you put a close bracket, then press enter. 90. So similarly, let's see, okay, for the fx also the same. So equals SUM, okay, put open bracket, select cell C2 until cell C6, and then put a cross bracket, press enter. So you can check your answer by using Excel. Now I go back to here. Okay, so far so good, Okay, next I'll move on to next one. Okay, I'll go for standard deviation first, since there are some information also required, okay, from the mean calculation. So I'll go for standard deviation first. Okay. Okay, so for standard deviation, the formula is also different between the group and also ungroup data, different formula. So for group data, the formula to calculate the standard deviation is using the total F instead of N now. It's using total F, total frequency, -1. Okay, and then multiply with total frequency multiply x squared. Okay, and then minus total fx, then bracket power 2, and divided by total f. Lastly, square root the whole things. Okay, you may find that seems to be quite long. The formula is okay. Okay, the technique is you just need to get ready a few columns. Just now when we calculate the mean, we already have the column for f and fx. Okay, these two we already have the answer in fact when we calculate the mean value. Only this one we don't have, which is fx squared. So that means we need to add one more column when you want to calculate the variance or standard deviation, which is fx squared column. Okay, so let us go back to the group data we already have. All right. So the blue one is the x column, right? The class column. X means the class. Okay. So it's blue color. We already have the data from the original question. The purple one is the frequency column. We also already have the value as well. Okay, from the original. And the fx, we already have the information when we want to calculate the mean value. Okay, mean value. So you already have the information here. So the problem now is we need to have one more column, which is fx squared. Okay, so what is the meaning of fx squared here? Fx squared means f multiply x multiply x, and that is the meaning. Okay, f times x times x. Okay, So since just now we already calculated we already have fx column, which is the green one. Okay, so actually I can treat this fx. I can get the information from the green column. Okay, this fx we can get from here, from this fx here. Okay, then how about this x? This x we can get from the blue column. I use blue. Okay, from this part. Okay, so let's try try one class first. The first class. Okay, how to get the fx square value? The fx square value, okay, is equal to 0, which is from the green column. I use green color. Okay, this is 0. Fx. Okay. Multiply with the blue x. Blue x is 0, so I use black color. Okay. So 0 multiply 0 is equal to 0. Okay, how about second class? Second class, the fx value is 30. Multiply with another x value is 1. Blue color. It's like this. 30 I use green color. Okay. 1 I use black. Right. Original. Like this. Okay. How about third class? Third class is the fx value is 32. 32. Okay. Multiply with another x value, which is 2. Yes. Any question from any of you? Want to ask question? Okay, 0. Right. So this is how you get the answer for fx squared. So far so good, Okay. So once you have the total fx, and also the total fx squared value, then the next step is we can substitute these 3 numbers into the formula of standard deviation. Okay. So we'll copy and paste the number into the formula. Okay. So at first we copy the formula first. First step, right? Yeah. Okay, I stop for a while. Any questions so far? Any question on how to calculate the fx squared column? Okay, right. Okay, so we start now. Okay, substitute the number. Okay, total f means this one, 90. Substitute to here. I use purple color. Minus 1 is still remain the same. I use black, original. No change. This one, total fx squared, how to get the value is from here, 300. Substitute this number to here. Okay. Then we move on to this term, second term. Okay. The numerator is total fx and then bracket power 2. So power 2, bracket power 2 remain the same, no change. Total fx, where can we get the information? From here, 124, the green one. Okay, so substitute this number to here. Then the denominator, total f, is 90. Yeah. Okay, put here. So I use color to differentiate. Can you see? I use purple, green, and this is orange. All right. So substitute the number first. So for your project, you can show the workings like this. Okay, you can show workings. Okay, right. Then the next step is to simplify this expression. Okay, we have to simplify the number inside the square root first. Okay, so this one you simplify. 90 minus 1 is 89. Okay, 300, I would suggest just put it there first. Okay, we try to simplify this part, the second term, this part. Simplify this one first. And then you may leave the answer in 2 decimal places enough. 2 decimal places enough. Okay, so 124 power 2 divided by 90. Okay, answer is 170.84. Substitute to here. So bear in mind, the number of the second term must be less than, it should be smaller, always smaller than the number of the first term. Why? Because the variance and standard deviation always positive. Okay, so this is the way you check your answer. Make sure that the difference should be positive number. Okay. Then if you are good enough, okay, you can use calculator to solve the problem. Usually, okay, I'll try to use 1 divided by 89 first. Okay, and then multiply with this number. Then square root the whole thing. You'll get 1.20 units. Okay, so any problem on the calculation part? 1.20 units. The units is depends on your X class. Okay, your class unit is in units. Okay, any question on this calculation? Okay, so how to interpret the meaning of standard deviation? What is the meaning? So that means that is the average difference of the number of aircon units between the 90 observed houses in the residential area and the mean, okay, is equal to 1.2 units. So that means the average difference of the aircon available, aircon units available in between the 90 observed houses and the mean value is 1.2 units. Okay. So far so good. Okay, I would like to teach you also how to use the Excel to check your answer. I want to teach you how to use Excel to check your answer also. Okay, so I go back to the Excel file. Okay, let's say now I want to calculate the fx squared. I use power tool like this, means square like this. All right. So we know that fx squared means fx multiply x, so which is the green color multiplied with the blue color. Right. Right. Maybe this I use green color so that you can see. Okay, this I use blue color. All right. Okay, fx maybe I use orange. Orange. Okay, so for the first class, how to get the fx squared then? Okay, I can use fx multiply with x, which is this number. Okay, press enter. Second class also the same. We use 30 multiply with 1. Okay, so continue the same process for the third class. 32 multiply with 2 and etc. Okay, so if you are skillful enough, you can just simply copy the formula for self row 5 and 6. You can copy the formula. Okay, so let's say now I feel lazy, I want to copy the formula. So how should I do? Okay, I can go to either cell D2, D3 or D4. I choose D4 since already formulated. I choose D4. Okay, move your mouse cursor until at this we call as the bottom right hand side of the cell D4, D4. Okay, until you see a black cross sign like this. Okay, then you left click the mouse and drag the mouse until cell D6. Then release the mouse. Okay, then you should be able to identify the fx squared values for all the classes. If you want to calculate the total fx squared, then what you can do is you can use the sum formula. 100. I check correct or not. Okay, this is the way you get the answer. All right, any question on standard deviation? Okay, some students may ask why I do not cover variance. Or actually, yes, variance actually the value of the variance is unable to be interpreted. Is meaningless to be interpreted by using the variance. We have to use the standard deviation when we want to interpret the value. Okay, we should use standard deviation. Okay, all right. Then I'll move on to the next measurement, which is mod. Ignore the question, mod. Okay, mod. So mod means the most frequent occurs value, most frequent occurs value or most frequent occurs object. Okay. So for mod, right? Okay. Then the first step is in order to calculate the mod value, the first step is you need to go to the frequency column, which is the second column. Okay, and check among this value, this F value, which value has the highest number? This one, right? Second class. Okay, 30. This class has the highest frequency. So we can conclude that this is the mod class. Second class is considered as the mod class. Okay, or sometimes it's called as model class because this class has the highest frequency, 30. Okay, so once you identify the mod class, then you can able to conclude your mod value. Okay, so how is the mod value? Mod value is equal to 1 here. Okay, the mod is 1 unit. So in short, in order to get the mod value for the group data, there are two steps involved. Step 1 is identify the mod class. Okay, how? You have to go to the frequency column, okay, to identify the mod class. The class with the highest frequency is the mod class. So in this case, it's second class. Second step is identify the mod value. How? You go to the first column, okay, first column, the class column, and check what is the value here. Because this is the single score frequency table, you can get the mod value directly, okay, without any formula at all, right? Answer is 1 unit. Okay, so how are you going to conclude the mod value? You can say that, okay, majority of the houses in the residential area in KL have 1 unit of aircon. Okay, most of the houses in the area have 1 unit of aircon. So far, okay, so far so good on the mod. Okay, if no question, then I'll move on to median. Okay, median, we know that is the middle number, middle number. Okay, so generally, in order to get the median value, this involves 3 steps. Okay, there are 3 steps involved. The first step is like, okay, we need to, the first step, we have to identify the median term. Okay? Term of median. That is the first step. Term means the location of median. It's not the value, but it's only the location, not the value, just the location only. All right. So what is the formula to identify the location? Okay, because this is group data, so the formula is term of total F divided by 2. Okay, term of total F divided by 2. For the ungroup data, the formula is term of N plus 1 divided by 2. N plus 1 divided by 2. For group data, no need to plus 1. Okay, no need to plus 1. Just put total F divided by 2. This is for the group data. So in this case here, what is the total frequency? Total frequency is this value, the total value from this column, 90. So we substitute 90 to here. 2 is the constant number. 1 divided by 2 is 50%. That's why divided by 2, because median means 50%. Okay. So simplify this, you'll get term of 45. So that means like median is at the location of 45. The 45th term is the location, okay, of median. So this is only the first step. Okay, this is step number 1 only. We haven't identified the median value exactly. We only know the location is at term 45. Okay. Then the second step now is we need to identify the median class. Okay. Second step, we have to identify the median class. How to do so? Okay. My suggestion is better for you to build a new column. It's called as the location or term column. Okay. This is for your own reference. No need to show the working to the examiner. Just for your own reference, so that you can identify the median class. Okay. Second step, median class. Okay. So how to do so then? Okay. So in this location column, we know that there are 25 frequency here, right? So we can conclude that the first term to the 25th terms are under the first class. Okay. How to get 25? 25 is because of frequency 25 here. So that means like those houses that have the lowest number of aircon are under the first class. Okay. Those houses that do not install any aircon at all are categorized under the first class, which are from term 1 until term 25. Okay, so T means term, T1 to T25 are under the first class. How about the second class? Second class should start from T26. Why? Because after 25 should be 26, right? Here, until which term? Until term 55. How to get 55? That is 25 plus 30. Okay. 25 plus 30, you'll get 55 under the second class, under this class. How about the next class? Next class should start from T56. Why? Because you say the last term under the second class is 55, right? So by logic, the next class should start with T56. Until which term? Okay, you can use 25 plus 30 plus 16. Okay? Sum out these three numbers, you'll get 71. Next class, the fourth class, you'll start from 72. Yeah? So it depends on this number here. After 71 should be 72. Until which term? Sum out these four numbers. Okay, you'll get 85. All right. Then the last class consists of only 5 frequency, 5 numbers, 5 houses are under this class. Okay, so that will be T86 until T90. There are 5 last terms are under the last class. Okay, so once you have built the location column, the next step is you should be able to identify the median class. How? Okay, we compare. This is the median term. Median term is T45. Okay, so you check T45 should be within which term then? It should be this one, right? T45 should be here under this second class. T45 is greater than 25, so it's not possible under the first class. Okay, T45 is also less than 56 also, so it's not possible under the third class. So it should be under this class, second class. Okay, under the second class. Okay, so this is the median class, step number 2. Okay, so how about step number 3? Okay, once you know this is your median class, then you should be able to get the median value. How? You go to the first column here, the X column, check. It's 1 exactly. Okay, so median is equal to 1 unit. I stop for a while. Any questions so far? So there are 3 steps involved. First step, identify the median term using this formula. Okay, term. Second step is identify the median class. So for median class, you need to build a location column. Okay, for you to identify the median class. Then the third step is identify the median value. That means you need to refer back to your X column, which is the class column. Okay, yeah. Any question on median? Maybe I believe this is new for you, new thing for you. So far, okay, all right. So yes, how to interpret? Yes, yeah.
No question. Yes.
Okay, good. Okay. So if you want to interpret the value of median for this question, then you can say that 50%. You should always start with 50%. 50% of the houses in that particular area have less than 1 unit of aircon installation. Okay? And another 50% of the houses have more than 1 unit of aircon in the house. Okay, done. Okay, Q1. Q1 means the first quartile, 35%, first quartile. Also the same, there are 3 steps involved in order to identify the first quartile value. 3 steps. Okay, first step is find the Q1 location first. Q1 means the first quartile or lower quartile. Okay, so what is the formula to identify the location? Formula is term of total F divided by 4. Now it's because it's quarter, so divided by 4. Okay, so bear in mind, this is total F, it's not total F plus 1, not plus 1, just total F. So in this case, okay, the total F is 90, substitute here. Divided by 4, you get term of 22.5. Okay, second step is identify the Q1 class. So in order to help you to do so, you can build a location column. Okay, now we need to fill in the blank. Okay, the first class is from T1 until T25, and etc. This one we already done just now. All right. Then the third step, No, not still second step. Okay, so once we identify, okay, this location column, the next is we have to check, okay, this term 22.5 is within which area then? 22.5, is that under the first, second, or third class? We'll check, 22.5 should be here, under this class, all right? Because 22.5 is between 1 to 25. 1 to 25. So that means Q1 is under the first class, okay, this class. And then what is the Q1 value? Answer is, you go back to your first column. 0 answer. Okay, 0 unit. So what is the meaning of Q1 equal to 0 unit? That means that 25% of the houses in the KL residential area have less than 0 aircon. Okay, and another 75% of the houses have more than 0 unit aircon in their house. Okay, Q3 means third quartile, or we call it upper quartile. So it's 75%, 75% percentile. So also the same, if you want to calculate the Q3 value, you also have to do 3 steps. First step, identify the term of Q3 using this formula now, because this is group data. So we need to use this formula to identify. So you may find that it's 3 divided by 4. 3 divided by 4 means 75%. Okay, so substitute 90 to here. 90 is the total frequency from here. Simplify, you get 67.5. So this is the location of Q3. 67.5 is the location only. Okay. The second step, build the location column and compare with the term of Q3. Okay, 67.5. Let us check. It's not in the first class, right? Because first class is for 1 to 25, so out. Let us check second class. It's for 26 until 55. This is 67.5, so out. Second class is not possible. Okay, so move on to third class. Okay, third class is between 56 to 71. Okay, match. Okay, it's within this range. So Q3 is under this class, under the third class. Okay. Okay, now is we need to check what is your Q3 value. So you go to the first column, check. Answer is 2 units. Okay, 2 units. So in order to interpret the value of Q3, you always start with 75%. Always start with 75%. So that means 75% of the observed objects, in this case, will be the 90 houses, have less than 2 units of aircon. And another 75% of the houses have more than 2 units of aircon. Okay. So this is example 1. You may find that for example 1, the classes are using the single score. The classes are using the single score. Okay, now I'll move on to second example. For second example, you may find that the classes now are given in the class intervals form. That means it's no longer exactly a score, but it's in the interval form. So, okay, so for the second example, I use the age distribution of workers in a factory. Okay, so from this group data, there are 10 workers between 21 to 25 years old. Okay, and 35 of them are between 26 to 30 years old. Okay, and then for the last class, the oldest one, there are 3 of them between 51 to 55 years old. So from the group data, we don't know exactly what is the age of each worker. We don't know, but we know that is in the interval, okay, in the interval class of age. Okay, so this is the advantage for the class interval frequency distribution. Okay, so if you have this type of data, okay, we call this as group data as well. So if you have this type of data, how are you going to calculate the we call it as the descriptive statistics that include the locality and also the dispersion measurements, like mean, mode, median are the locality. Standard deviation, variance are considered as the dispersion measurement. Okay, so how are we going to use this group data to calculate the mean, mode, and others? Okay, so let's start with mean. Okay, so originally the age value already given to us, but it's in the interval form, right? And then you may find that actually there is a gap in between the higher number, the highest number of the first class and lowest number of the second class. Okay, there is a gap in between, right? Which is 25.1 until 25.9. Okay, it's not included in the class. Okay, so for this type of class, we call this as the limit class. Okay, there is a name for this. We call this as limit class because there is a gap. Okay, limit class. So this one we can give a name for this. It's called as a limit class. It's a gap. So we need to close the gap first, before we can do any calculation for this type of data. We need to close the gap. There are few ways actually can fill the gap. All right. So I'll use the degree method because when you proceed to degree, the Melbourne counterpart, I suggest to use this method to close the gap. Okay, that is build the boundary class. How to do so? That is for the first class, you can just put 21 to less than 26. Okay, less than 26, which is equal to the lower value of the second class, right? This is how you convert. Okay. Then how about the second class? Also the same. Okay, you will start with 26. Okay, and then put until less than 31 in order to close the gap. This is the method suggested by the degree lecturer. So I just share with you. All right. There are a few methods again to close the gap. This is one of the methods. All right. So third class is from 31 to less than 36. That means it's not include 36. Not include 36. Less than 36. Right. Fourth class is from 36. Okay. To less than 41. So continue the same process until the last class for the boundary class. So the last class is from 51 to less than 56. So far so good? Are you okay with the boundary class now? So now we already close the gap, normal gap, okay, in between two classes. So far okay, all right. So in order to get the mean value, we know that we need to use this formula, but the problem is for the we call it as the class interval form, you may find that there is no exact, exact x value to represent each class. There is no exact value. X, we don't know, right? So we need to identify the x value for each class, x value for each class. Because the problem now is the classes are given in the interval form, okay? There is not exactly x value, so we need to calculate first. And this x value is given a name. It's called as midpoint of each class. Midpoint of each class. Okay, and this is the x in fact. So in fact, the midpoint actually is the class column. It's the class column. Okay. Okay. So what is the first class x value then? Okay, we have to use 21 plus 26 divided by 2 in order to get the midpoint for the first class. So it's 23.5. Okay, 23.5. So that means that we are going to assume the 10 workers who are under the first class have similar age, which is 23.5 years old. Okay, all of the 10 workers under this category have similar age, which is 23.5 years old. This is our assumption. Okay, had to make All right, this is the limitation for the group data. Yeah. Okay, how about second class? Second class is the midpoint is 26 plus 31. Divided by 2, 26 plus 31 divided by 2. Then you get 28.5. Plus class is 51 plus 56 divided by 2. You'll get 53.5. So far so good, All right, midpoint, So actually this is the class column. So I use blue color. All are related one. These three columns are related. Okay, I use blue color. So this is how you get the midpoint. So we need midpoint value when the classes are given in the interval form. It's no longer the single score. So we need to calculate the midpoint by ourselves. Okay. Okay. Then what's the next? Next is we need to get ready the frequency column. Frequency column already given. Okay. Originally already given to us. example 2 just now. The F column already given to us, so we can just copy this column. Then we put here. All right. If you want, you can also try to calculate the total frequency value. Okay. So once you have the X and also the F column, then you can build the Fx column now. Okay. Fx column means F multiplied X. So for the first class, the F value is 10, right? Multiply with the X value is equal to 23.5. You get 235. Yeah, 235. Okay. You can use purple color so that you can see. Yeah, purple color. So purple is 10. Okay. Maybe this one I use blue color. All right. I use blue. Okay. So second class also the same. In order to get the Fx value, we use 35 multiply with 28.5. This is purple. This is blue. So continue the same process for other classes. Then what is the next step? Next step is to sum up the value for F and also Fx. Sum up the value for only these two columns. Others no need. Only these two columns, F and Fx. So the total F is 100. The total Fx is 3475. Okay. So once you have the total value for these two, you can substitute the numbers into the mean formula for group data. Group data formula mean. Okay. So the numerator is total Fx, which is this number 3475 put here. The denominator is total F, this number. So substitute to here. Okay. So simplify, I get 34.75 years. You may round the answer to whole number, which is equal to 35 years. Okay. So that means the average age of the workers, the average age of workers. Okay. I have to add some more. The average age of workers. Is 30. You can put 34.75 years old. Okay, or 35 years old. So far so good, So for the class interval form, you need to get ready one more column, which is the midpoint column. And then how to calculate the midpoint? Midpoint, you have to use the boundary class. Okay, you have to use the boundary class, not the limit class. You have to use the boundary class to identify the midpoint. So far so good, You can also use Excel to do the calculation if you want. You can use Excel. Okay, now I move on to standard deviation first, because for standard deviation, we need all this column information plus the Fs squared. Okay. So for standard deviation, we know that, okay, the group data formula is still the same. Okay, it's using this formula to calculate the standard deviation for group data. Right. So just now we already have the total F, total Fx. We already have the information. Now is the total Fx squared. We don't have the information only. So you need to build extra column on the right hand side. Okay, after the Fx, which is this Fx squared. So for the first class, what is the Fx squared value? Fx squared is 235. 235 multiply with the midpoint 23.5. 23.5. To use other color so that you can see the information. Okay. This one I use green. This one I use blue color. So 235 is the green number from the first class. Okay, the first class fx, and then another x is from the blue column. Yeah. Okay, fx squared means fx multiply x. Yeah, fx times x. So it's this column times this column. Okay, so continue the same process for other classes, then you'll get total fx squared of 127475. So you must get ready this table first. Okay, so once you have this table, you can substitute the number now into the formula of standard deviation. Okay, so we start from here. Total f is 100. 100 is from this column. Total f put here. Okay, this one also the same. Total f 100 put here. Okay, total fx squared is the orange color. Okay, it's in orange color, this one. So substitute to here. This part, the numerator, total fx is this one. Remember to put bracket power 2. Okay, then simplify the mathematical expression. So this one is simplified is 1 divided by 99. This number, I suggest to leave it there first. Copy, right? Don't disturb. This one simplify, you may leave the answer into decimal places. Okay. So you can compare also the second term, this term always less than the first term. This is the way you check your answer. Okay. All right. Then you use 1 divided by 99 and that multiply with this number. Then square root the whole thing. You'll get 8.24 years. So that means the average age difference between the 100 observed workers and the mean is 8.24 years old. Any questions so far? So in short, in order to get the standard deviation, you need to have the x column, which is midpoint, f column, which is the frequency, followed by fx and fx squared. Okay. Okay, then I'll move on. If no other question, I'll move on to next measurement. That will be mod. Okay, mod. Okay. So in order to get the mod value, okay, for the group data, also have to involve about at least 2 steps. Okay, you need to identify the mod class, followed by using the formula to calculate the mod value. Okay, so the first step, you can try to copy the ungroup data, all right, but make sure that the classes must be in the boundary classes. Boundary class, all right. So you need to do the conversion first. The first step, you need to make sure that you have to use the boundary class. Okay. Frequency, you can just copy directly from the table, the original table. Okay. Okay. In fact, you need these 2 columns. These 2 only. Okay. So now is we need to identify the mod class. The first step, mod class. Okay. So you go to the frequency column, check among these values, this f value, which one has the highest number? Answer is 35, right? 35 is the highest frequency value among these classes. Then we can say that the second class is the mod class. Okay, this class is the mod class. So that means that your mod value is between 26 to 31. Your mod value is between 26 to 31. Yeah, because for this class, the frequency has the highest number as compared to other classes. So this is the mod class. And the mod value is between 26 to 31, but we don't know what is the exact value. We don't know what is the exact value now. So if you want to know the exact value of mod value, you can use formula. Formula no need to by heart, will be given in the exam. So this formula is applicable when the group data are provided in the class interval form. Then we can use this formula, all right, to solve the problem, right? So in the exam, this formula will be given. No need to by heart, okay? But we have to understand the meaning of each symbol. Okay, so we start from this one, LMR. Okay, you can. So what is the meaning of LMR here? LMR means the lower mod class boundary. Okay, lower mod class boundary. So in this case, the lower class boundary is 26. Okay, 26 is the lower class boundary, and 31 is the upper class boundary for mod class. So far, okay? For L mod, yeah, it's from here, blue color. Okay. Then how about this one? Triangle 1. Triangle 1, okay, you confused, you can go back to here, check. Triangle 1 here is referred to the model class frequency minus the frequency for the class before the model class, okay? Minus the frequency for the class before the model class, okay? So if this is the mod class, okay? Mod class, so that means 35 is the frequency for the mod class, all right? For the model class, 35. So triangle 1 is 35 minus what? Minus the frequency of the class before model class, which is 10. Okay? So 35 minus 10 is the triangle 1 value. Okay? So 25 you substitute to here. How about triangle 2? Triangle 2 means the mod class frequency minus the frequency for the class after the model class. After the model class is this one. This another third class, and the frequency is 16. So we substitute 16 to here. 35 minus 16 is 19. Then you substitute 19 to the triangle 2. So you may find that like the triangle 1 and triangle 2 always positive. Make sure your triangle 1 and triangle 2 value always positive. Why? Because we always use the mod class frequency minus the frequency before the class or after the class. Okay, so your value for triangle 1 and triangle 2 must always positive. So far, okay, yeah? Okay, then how about C? C is referred to the class size of the mod class. Class size. So we have to use the boundary class, not this one. We have to use the boundary class. We should not use the limit class. Remember, have to use the model class, boundary class value. So it's 31 minus 26. 31 minus 26 as the C value. I stop for a while. Any question on L mod, triangle 1, triangle 2, and C? Any problem so far?
No,
This
sir.
formula, yes.
No. Don't have.
This formula can be new for all of you. Okay, all right. So then, okay, then the next step is you have to simplify this expression. All right. So 26 is the first term we just copy directly. Simplify this part, you get 44. Simplify this one is 5. Right? Then simplify, you get 28.84 years. You can round the number to whole number, will be 29. All right. Then you can say that most of the workers at that factory are at the age of 29 years old or 28.84 years old. Majority of them, okay, have this age. Okay. Okay, I'll give you another example later on. Don't worry, because I know that this is new for you. We'll go for another example later on, which also involve the class interval question. Okay. Then the next is median. Okay, median. So for median, also the same. Make sure that you need to have the boundary class. Okay? You need to have the boundary class. That means you need to convert the limit class into boundary class. Okay? You need this. Get ready. Okay, put it here. Then the next class is frequency. The column. We need the frequency columns. So just copy the data for frequency into here. Okay. Okay, then you can start to do your calculation now. First step is to identify the median term. That means the location of median, right? First step. So what is the formula? Formula is using this one, term of this. Identify the location first. It's at the term of 50 for this case. Term of 50. So it's T50. Okay, second step is to identify the median class. So in order to help you, what can you do is you can build a location column. It's for your own reference only. Okay, so how then? Okay, for the first class is consists of 10 frequency, right? So that means the workers with the lowest age, okay, 10 of them should be under the first class. So that means it's from T1 until T10. Okay, so these 10 workers are the youngest, okay, among the workers in the factory. So I put it here. So how about second class? Second class is from T11 until T45. How to get 45? That is 10 plus 35. So I'll get 45 here. Third class is from T46 until T61. How to get 61? That is 10 plus 35. plus 16. Okay, plus these three numbers, you'll get 61. Another way is you can use 45 plus 16 also okay. 45 plus 16, you'll get 61. Next class is from T62 until 75. How to get 75? You sum up these four numbers. These four frequency, you'll get 75. Okay. Next class is from T76 until 87. 87 is the sum of all these frequencies. Okay. Next class is until 97. 88 until 97. 97 is the sum of all these frequencies. Last class is start from T98 until 100. Okay, so that means there are the last three terms are under the last class. That means there are the oldest workers. Three of them only, which are T98, 99, and 100 are under the last class. Okay. So once you already identify the location column, okay, the next is to identify the median class. Okay, we check. T50, is that under the first class? No, because first class is for 1 until 10. Okay, this is T50, So first class is out. Second class is for 11 until 45. This is 50, so it's greater than 45, So it's not possible under the second class also, right? So move on to third class. Okay, third class is for 46 to 61. Okay, it seems to be is within. 50 is within 46 to 61. So now we can conclude the median class is under this class. This is the median class. Okay, this is the median class. Then what is the median value? Okay, at the moment we only know the median is between 31 to 30, but less than 36. Okay, the median value is between 31 and less than 36. That's all. Okay, we don't know what is the exact median value now. So how to calculate the exact median value? We can use formula to help us. Okay, the formula no need to by heart or be given in the exam also. So let's see the formula. So this is the formula. So we need to understand the meaning of each symbol. LM, what is the meaning? LM means, you can go back to here. It's the lower median class boundary. So in this case, it's 31. Okay, 31. So we substitute 31 to here. Okay. Total F divided by 2, you already have the answer just now, 50. Okay, so you can substitute 50 directly to here. Here is 50. Okay. Okay, then how about here? This one, total F at the M minus 1. What is the meaning? We go back to here. Check. What is the meaning? This one means cumulative. Very important. Cumulative means total. Okay. Total frequencies. Okay. Frequencies, that means more than one frequency. Total frequencies for the classes before the median class. Before the median class, how many classes altogether? This is the median class. So before the median class, we have first class and second class. All right. First class and second class, there are two classes. Okay. So the cumulative frequencies before the median class is 35 plus 10, which is 45. So substitute to here. 45. So far okay for this one, 45. So 45, it should be include 35 plus 10, the second class and the first class. Okay, you have to follow the definition of this symbol. 45. Okay. But anyway, one way for you to check the answer is this term is always greater than 45. Okay, this value must always greater than 45. Must be logic must be greater than 45. This is the way you check answer. Okay, how about this one? FM. Okay, FM means the median class boundary. This is the frequency. Frequency for median class. I haven't changed. This one should be the frequency for median class. Median class frequency. This one should be frequency. Later on, frequency. So this is the frequency at the median class. Okay, we know that this class is the median class. So what is the frequency? 16. Okay, for this class, the median class is 16, the frequency. So we substitute 16 to here. Okay, so this one is only involved one class only, median class. This one is involved all the classes frequency before the median class. Okay. How about C? C is the class size. We have to use the boundary class, okay, to calculate the class size, which is 36 minus 31. Okay. Okay, next is we have to simplify. Okay, 31 remain the same, don't change. This one is 50 minus 45, you'll get 5 positive. Okay, 16 put here. So bear in mind for this part, it must always positive. This part, if you simplify, should be a positive number. Okay, how about here? 36 minus 31 is 5. Put here. So simplify, you'll get 32.56. Yes. So what is the meaning? That is 50% of the workers are below than 32.56 years old. And then another 50% of the workers are above 32.56 years old. Okay. So any question related to median for class interval question? So there are 3 steps involved. Right? Identify the median term, followed by median class and the median value. It can be new for you, this formula for all of you. Okay, now move on to Q1. Q1 means the first quartile or lower quartile Q1. So also the same, you have to follow the 3 steps to calculate the Q1 value. First step is identify the Q1 location, followed by Q1 class, and then the Q1 value. Okay, so we start from Q1. This is the Q1 term. Q1 term, you need to use this formula. Total F divided by 4. Okay, so it's term of 25. Second step is identify the Q1 class. Okay, Q1 class is better for us to build a table. So make sure that you need to add this table, this column, the boundary class column, followed by frequency column, followed by location column. Okay. So once you have the information for these 3 columns, you can start to identify your Q1 class. Okay, how to do so? Your Q1 is 25, T25. So let's see whether it's under the first class. No, right? Because the first class is for 1 until 10 only. So first class is out. Okay, second class is for 11 until 45. Okay, yes. Because 25 is between 11 to 45. So T25 is under the second class. So that means the second class is the Q1 class. This class is the Q1 class. So that means your Q1 is between 26 but less than 31. Okay. Your Q1 value is between 26 but less than 31. Okay, so in order to get the exact Q1 value, you have to use formula. So we copy this formula first. Okay, we have to modify the formula, in fact. Okay, modify the formula. Okay, what do you need to modify? Only this one. Change to 4. Okay, instead of 2, use 4. Why? Because 1 quarter is equal to 1 over 4. Okay, so we use 4 now instead of 2. Others remain the same. So let's try to check. Okay, how to replace the number. LQ means the lower boundary of the first class, first quartile class. Okay, first quartile class, the lower boundary value is 26. So substitute this number to here. Okay, this part, total F divided by 4, you already have the answer, which is 25. So substitute to here, 25. In fact, the whole thing is 25. Yeah, this part. Okay. Okay, how about here? This is the total frequency. Okay, the cumulative frequencies before the Q1 class. Okay. Before the Q1 class, only 1 class. Right? For this question, only 1 class. Okay, so the total frequency before the Q1 class is only 10. It's only 1 class, which is 10. So substitute to here. Okay. How about the denominator frequency at the Q1 class? Answer is 35. Exactly 35. So put here. I should use red color. Okay. Very sensitive, 35. Okay, C is using 31 minus 26. Okay, so simplify this, you'll get 28.14 years. So this is the way you interpret the value of Q1. You always start with 25% less than, and then 75% more than. Okay, okay, then Q3 also the same. Okay, follow the 3 steps. first step is identify the term of Q3 by using this formula now. 3 divided by 4, yeah? Because 3 divided by 4 is 75%. So do this one first step, okay? Second step is to identify the Q3 class. So that means you need to build this table. Make sure that you have the boundary class column, frequency column, and location column. Okay. Then you compare your T75 should be under which class? Okay, let us check. This is T75. Yeah? 75 is more than 10, so first class is out. 75 is also greater than 45, so second class is out. Right? Third class is until 61 only, yeah. But our Q3 is 75 term, so that means third class is also out. Okay, it's not possible. Okay, move to here. Fourth class is for T62 until T75, and then your Q3 is exactly T75. Okay, so it's the last term under this class. Okay, it's this term, okay, under the fourth class. So that means that this is the Q3 class. For this question, this is the Q3 class. If this is the Q3 class, that means your Q3 value is between 36 but less than 41. Okay, between 36 but less than 41. Okay, so now how to get the exact value of Q3? You have to use formula. You need to modify the formula. Yeah, only this part you need to modify this part. Okay, just use 3 divided by 4. So let's try to substitute the number into each variable. Okay, so LQ means the lower class boundary for the third quarter class. So it's 36. Lower class boundary at the third quarter class is 36. Substitute to here. Okay. This part you have to substitute 100 as the total frequency. Yeah? For this question, the total frequency is 100. Okay. So 100 multiplied 3 divided by 4. So you should be able to get 75. Okay. This part is the total cumulative frequency. Yeah, before the Q3 class. Okay, this is the Q3 class. So before this class, there are 3 classes here, right? Which are first class, second class, third class. So that means we need to sum up the total frequency value. Should be equal to 61. 10 plus 35 plus 16, 61. So substitute to here. Okay. Make sure that you have to sum up the cumulative frequencies, plural, the cumulative frequencies before the median class. And before the this is a Q3 class. Okay, then FQ means the frequency at the Q3 class is 14. Okay, so substitute this to here. Last part C we have to use the upper boundary 41 minus the lower boundary 36. We have to use this one, not this. Cannot use this one. This is because this is a class limit. Got a gap. So we cannot use this one. We have to use this one. Remember, this one. Okay. So 41 minus 36. Okay, simplify. You get 41 years old. Okay, 41 years. Right. So since this is Q3, you always start with the explanation now, with 75% below, and then another 25% above. Okay, so far so good. Okay, last example for today is also the class interval, because I use another example. It's also class interval because I know that most of you are still new with the formula for class interval group data. Okay, so I use this as the last example today. So the following are the test score of statistics obtained by the class A students. So in total, there are 25 students in the class only. The class A students consists of 25 of them. Okay, so there is one student only scored the test. The test score is 30 to 39. So that means quite bad. This student fell badly. And then 2 students have the statistics test score between 40 to 49. And the outstanding student has 1. It's managed to get the score between 90 to 99. Okay? 90 to 99. Okay, so this is the information we have. And from this group data, we don't know what is the exact test score value for each student. We don't know the exact test score value. We don't know. We only know that the test score value is given in the class interval, okay, in the interval form. So if you have this type of data, then you may use this to identify your mean, mode, median as well for all the measurements for this class A statistics test score, right? So we will start from mean value, okay, mean value. So remember, okay, because the score classes are given in the limit form, there is a gap in between. So you need to, okay, you need to change the classes side into boundary classes at first step, all right? So for the first class, we have to put 30 to less than 40. Okay. Change the class interval from class limit to class boundary. Okay. Second class is from 40 to less than 50. Yeah. Last class is 90 to less than 100. So make sure that you know how to do this, because if this one is wrong, then that means all calculation will be wrong. Okay. Make sure that you know how to change from limit class to boundary class. This one is called as a limit class. Okay, limit class, because there is a gap in between two classes. So we call it as limit class. Okay. So once you already have the boundary class, okay, you need to have the midpoint value to represent the value of each class. Because why? Because now, right, for this interval class, we don't know what is the exact value for each class. We don't know. Yeah? So we need to get a midpoint, at least one midpoint to represent the first class. Okay. So what is the midpoint for the first class? First class midpoint is 30 plus 40 divided by 2. So it's 35. Okay. So that means we have to assume there is one student, right, with the lowest score. Right? His score or her score is equal to 35 marks. Okay. How about the last class? Last class, the midpoint is using 90 plus 100 divided by 2. Okay. Also got one student, right? So we have to assume that this student scored 95 marks for the statistics test. One student, we have to assume it's 95 marks. For group data, we have to do this assumption. Maybe it's not correct, but roughly, roughly this number. Okay. Similarly, for second class, also the same. Got two students, right? So assume that these two students scored 45 marks for the statistics test. Okay. So make sure that you have, you must have get ready, the X column, followed by the F column. Okay. And then the last column that you need for the mean calculation is fx. So that means is f multiplied x. Frequency multiply the midpoint value. So for the first class is 35. Okay. 1 multiply 35. Second class is 2 multiply 45. Third class is 6 multiply 55. Last class is 1 multiplies 95. Okay. So once you have the xx value, the fx value, then you sum up the value for fx and also the f column. All right. So once you have these two numbers, substitute these two numbers into the formula. So mean is 1625 divided by 25. You get 65 marks. So that means that the average score of statistics test is 65 marks. Okay. Or you can say that on average, each student score 65 marks in the statistics test. Okay, next example, it would be the standard deviation. All right. So for standard deviation, you need to add one more column, which is fx squared. Based on what you have from your mean calculation, you need to add one more column, which is fx squared. Fx squared means fx multiply x. Okay, multiply this one. Okay, this one, use this column. Multiply with the green column. Okay, then you can get the orange column. I should use darker green. This green is too bright. Should use this green. Okay? Then you can calculate the orange one. So once you have the fx square value, you sum up, okay, the column for fx square, fx, and f columns. Then we substitute these three numbers into the formula. Okay. So simplify, I get 14.1 marks. This one I skip already, because it should be quite familiar. But the most important is this one. Remember to change to boundary class. Make sure that it's already in the boundary class. Some students may ask, what happens if the question originally in the boundary class, then no need to do any amendments. You just continue using the boundary class value. If the classes already given in the boundary class format. Okay, there is no more gap in between two classes. Then you can continue using these boundary classes to calculate the midpoint value. Okay, then the next will be mod. Okay, mod. Okay, also two steps involved. First step is identify the mod class first. First step, mod class. How? You have to go to the frequency column. Check which class among these classes which class has the highest frequency. That means which class has the most students been assigned to. Most students been assigned to for this question. Okay, check. Oh, okay, this class has the highest frequency 8 compared to others, right? So this class has the highest frequency. So we can conclude this class is the mod class. Okay, mod class. And the mod value should be between 60, but it's less than 70. Okay, so step 2 now is, in order to identify the exact mod value, we need formula. So you copy the formula for your formula sheet as step number 2. Okay, so L mod means the lower boundary of the mod class. Lower boundary of the mod class is 60. Put here. Triangle 1 is the difference. Is the difference between frequency at the mod class and the frequency before the mod class. Okay, frequency is, you check this one. Frequency for the class before. For the class, that means only one class before the model class. One class before the model class. So that means you should only include this class only. The frequency for this class only, when you want to get the difference between the frequency between the mod class and a class before. So it's using 8 minus 6. Then you should be able to get 2. Okay, 8 minus 6, which is the triangle 1 value. So this triangle 1 value has 2 parts here and here. So substitute the same number 2. Okay. Then how about triangle 2? Triangle 2 is using 8 minus 4. 8 minus 4. So answer is 4. So put here 4. Triangle 2. Okay. C is using the class boundary class size. Class boundary class size is 70 minus 60. So simplify, you'll get 63.3 marks. So that means most of the students in class A obtained 63.3 marks in the test. Okay. So for mod, got 2 steps involved. Okay, how about median? Median got 3 steps. Okay. First step is identify the location of median using this formula. Divided by 2. All right. And then because this is group data, so we have to use total F, not n plus 1. N plus 1 is for the ungrouped data. For group data, we have to use total F. Okay. So it's at the location of 12.5, first step. Second step is identify the median class. So you need to get ready this table. You can show these 3 columns. Easy for you to show these 3 columns. All right, so let's check again. For location, okay, the first class has only one student. So that means the first class has only 1 term, okay, which is T1, only 1, because only 1 student there. How about the next class, second class? It should start from T2 until T3. How to get T3? There is 1 plus 2. 1 plus 2 is equal to 3. Put here. Next class should start from 4, term 4 until term 9. How to get term 9? There is 6 plus 2 plus 1. Okay? Sum up these three frequency, you'll get 9. Next class is from term 10 until term 17. How to get 17? Sum up these frequencies. Okay, you'll get 17. Next is term 18 until 21. 21 is sum up of these frequencies. Okay, then we have, okay, the second last class is from 22 until 24. Okay, the frequency is 3, right? That means like there are three terms are under this class, which are 22, 23, and 24. Okay, then the last class, the frequency is 1. So that means only one term. The last term is belong to the last class. Yeah. Anybody want to ask question? Or yeah. So it's T25. Yeah. Only because only one student under the last class. So only one term, which is T25. And this student scored the highest mark in this test. Okay, with the highest mark. T1 is the student with the lowest mark in the test. Okay, yeah? All right. So once you already have all these columns, then you can identify the median class now. Okay, we check. T12.5, is that under the first class? No. 12.5 is not under the first class because first class is only for T1. So first class out. Second class, no also because 12.5 is greater than 3. So out. Second class is out. Third class is until term 9. But the median term is 12.5, greater than 9, right? So out. Third class is not possible. Okay. Next class number 4. Class number 4 is from 10 to 17 term. Yes. Okay. 12.5 is within this range. So we can say that this is your median class. This is the median class. Okay. And the median value should be between 60 but less than 70. Okay. 60 but less than 70. This is the median value. So how to get the exact median value? Copy the formula, this formula. We need this formula to help. Okay. So L is the lower median value. Lower median is 60. Substitute to here. Okay. Total F divided by 2, we already have the answer, 12.5. Put here. Okay. 12.5. The whole thing is 12.5. This one is cumulative frequency before the median class. Okay, before the median classes, there are quite a number. Before the median class, we have these 3 classes. So we need to sum up frequency for these 3 classes. Okay, which are 6 plus 2 plus 1. You'll get 9. Remember, this one means like all of the frequencies before the median class. So we need to include first, second, and third class. Okay. Okay, FM. FM is frequency at the median class only. Median class frequency. Okay, I need to change. So it's 8 here, red color. Okay, last part C. C is the class size of median class. Remember, have to use the boundary class. 70 minus 60. We cannot use this one. All right, use this part, this column. Okay, now simplify. You'll get 64.4 marks. So that means 50% of the students, okay, scored 64 above 64.4 marks in the test, and another 50% scored above 64.4 marks in the statistics test. Okay. Okay, Q1. Q1. Okay, so Q1 also the same. So I am not going to say too much because I believe that you should be able to refer from your notes later on. This one should be the first quartile frequency, class frequency. So involve 3 steps. Okay, first step, identify the first quartile locations. Second step, build this table, and then identify your Q1 class. Third step is use this formula to calculate the exact value of Q1. Okay, Q3 also the same. This one should be third quartile class frequency. Okay. So also the same, follow the 3 steps involved to get the answer. All right. So the explanation always started with 75% below and then 35% above. Okay, I stop for a while. Any question related to the calculation of numerical measurements for group data?
No, sir.
So far, okay, so far so good,
Yes, so
okay,
far so
all right,
good.
yeah. Okay, I think last week, right, we also already studied how to draw the histogram. There is, okay, so there is one usage of histogram, okay, that is we can identify the mod value. We can only estimate, in fact, we can estimate the mod value by using the histogram. Okay, so I'd like to show you how to identify or estimate the mod value by using histogram, by using the example of this test score. Let's say we use this example, all right? So when you want to draw the histogram, make sure that the classes must be using the boundary class. That means no more gap in between two classes. I use this one, all right, as the x-axis. Okay, so we can use this one as the x-axis when you draw the histogram. And then the y-axis is referred to the frequency column, which is this one. So you can put number of students or frequency. Both are accepted, okay, for the title of y-axis. Okay, so we need these two columns information when you draw the histogram. All right, so you can use Excel to help to draw the histogram. Okay, so once you already built the histogram, then okay, you identify among these bars, which bar has the tallest height. Tallest height is this one, right? The tallest with the highest height is this one, right? So that means we can say that this class is the mod class, okay, which is from 60 but less than 70, and this is the mod class. So the mod value should be between 60 but less than 70. Okay, so how to identify? How to identify the mod value then? Okay, so what can you do? Yeah, you can draw two, we call as the two cross-sectional line. So how? Okay, I'll start with this. All right, okay, you can go to the bar with the tallest height, the highest height. Okay, you try to draw a line, a straight line that join, okay, in between this point, okay, this corner point with this point. Okay, using ruler, draw a line that connect this point and this point. Okay, then okay, use ruler again, draw a straight line that connect this point and this point. Right. Then go to the intersection point between these two lines, which is here. Okay, use ruler, draw a vertical straight line. Okay, draw. Okay, just put here like this. Draw a line. Okay, connect this line from this point until the x-axis. Okay, and go to this x-axis, check what is the value. If you are using the graph paper, you can check what is the value. Your value should be between 60 but less than 70. Let's say you get 63. That means the mod for this question is 63 marks. Okay, so that means most of the students managed to get 63 marks for the statistics test. But when you ask me, is that accurate? Answer is not really accurate. Because it's only estimation. I still prefer to use formula to identify the mod value. Better use formula instead of using histogram. Okay, histogram sometimes is also not really so accurate. Better to use formula. Okay. So this is for the usage of histogram. We can estimate the mod value. So far so good. Okay, Okay, then the last one I think will be the ogive curve. Okay, ogive curve. So you may ask, I think, okay, yeah, last week already explained to you. Some of the usefulness of ogive curve is you can identify the Q1 and also the median value and also the Q3 value, you can estimate the Q1, Q2, and also the Q3 value by using ogive curve. Okay, so let's say I use the same data. I use this data just now, the statistics score among the 25 students again. I use the same data. All right, and then from there I try to build this table in order to draw the ogive curve. Okay, so make sure that you must have the boundary class column, so that there is no big gap. There is no gap in between two classes. All right. And then you must have the frequency column as well. Okay. Followed by the cumulative frequency. Cumulative frequency column, how to calculate the frequency? Okay, cumulative frequency means total frequency. So in this case here, for this class, we have one student scored less than 40 marks. Okay, so one student. For the next class, how many students scored less than 50 marks? Answer is, if you really want, you can add one more column. It's called as the less than score class. If you really want, you can add one more column, which is called as less than. Okay, less than class column. Okay, then how about the next class? Next class, we have 3 students scored less than 50. 3 students. So how to get 3? There is 1 plus 2. Okay, for the next class, we have 9 students scored less than 60 marks in the test. How to get 9? There is 6 plus 2 plus 1. Okay, next class, we have 17 of them scored less than 70. 17 of them scored less than 70. How to get 17? There is 8 plus 6 plus 2 plus 1. Okay, next class, 21 of them scored less than 80 marks. That is the sum of this. Okay, last class, the next class is 24 of the students scored less than 90 marks. Okay, and 25 of the students scored less than 100 marks. How to get 25? That is sum of this. Right. Then the next step is you have to build another column. It's called as the cumulative frequency percentage cumulative frequency column, so that we can convert all the cumulative value into percentage number. Okay, make sure that you have to convert to percentage number. Okay, so for this class, what is the percentage of cumulative frequency? That is 1 divided by 25, right? Multiply 100. 100 because we want to convert to 100%. That's why we multiply with 100. 25 is because the total numbers in the class consists of 25 of them. Okay, so 25 is the denominator. The second class percentage cumulative frequency is 3 divided by 25 multiply 100, you get 12. Okay. Okay, then how about this class? This class will be 24 multiply 100, then divided by 25 lah. Right? Then you'll get 96%. So once you have all these figure, the cumulative frequency figure, okay, then the next step is it's better for you to add one more point, so that your ogive curve is touching to the x-axis. So it's better to add one more coordinate, okay, which is when the score is less than 30, okay, less than 30, or you can just put 20 to less than 30 lah. So no student scored this value, right? And the cumulative frequency is 0. Percentage is also 0 lah. Okay, you can add one more point or coordinate. Okay, so that your ogive curve is touching to the x-axis. Okay. So now is, maybe I can show you one more time. Okay, how to use the Excel to identify your to draw the ogive curve. To draw the ogive curve. Maybe I can just copy this. Copy this. Simply use Excel. I try to increase the size. Okay. This one, it should be, okay, I can have one more column here. This one I'll put this is less than, okay, less than class. Okay. So for this, okay, the first class, this is the additional class, is should be okay. I use gray color. Okay, so for this class, we call it the upper boundary lah. Okay, I use the word upper boundary. All right, upper boundary. Then you're not confused. Upper boundary. Upper boundary for this point is 30. Yeah, less than 30. Upper boundary. All right. Okay, for this class, the upper boundary is 40. Okay, so 50. Cumulative frequency percentage. Okay, I try to use formula now to get the answer. So this is for this one is 96. This one I try to hide so that you will not get disturbed. Okay. Hide. This one I increase the class width. I put like this. Okay. So in order to draw the agile curve, you need the upper boundary value plus the percentage cumulative frequency. Okay. So this one can be your x. This is your y. Okay. Percentage cumulative frequency is the y variable when you want to draw the agile curve. Okay. So I try to select this number first. The y value first. All right. I highlight. Then I go to insert. Agile curve, so I choose this one, agile. Okay. But you may find that actually the suggested agile curve from the Excel is not perfect. So we need to do some adjustment. What can I do is we go to the quick layout, choose layout number 10. All right. Why? Because if you choose layout number 10, got empty boxes for you to fill up the title for X and Y axis. Okay. Because for this agile curve only involve one variable, which is the test score, right? The statistics score. So we do not need to have any indicator for this diagram, so we can delete. Okay. And for the x-axis, you can give a name for this. You can say that this one will be this. This is the test score, right? Or you can just put score, or statistic test score, or just put score. Okay, and then for the y-axis, this one you need to put the title. It is no longer frequency. It's not frequency, but it's called as the percentage cumulative frequency. Okay, then how about the title? Title will be agile curve. Agile. For if you want, you can be more specific. For this is for maybe the scores. Anything else missing? Oh, you may find that the value also, right? Not logic. This value for the x-axis not logic. So we need to select the correct value to represent each coordinates. So what can you do is you can select this part, okay, until you see a box. Then you right-click your mouse. Right-click the mouse. It should be like this. Okay, one more time. Right-click the mouse. Okay. Then you should be able to see this dialog box. You have to use this one. Select data. This one. Okay. Then you click on the edit button. Okay. Now you're asked to select the label range for the x-axis. So we should start with this number. Okay. A2 until A9. Okay, so once you select these numbers, you may find that the figures appear here, okay, on the x-axis. So to confirm, you just need to click on OK button. Okay, click on OK to leave the message. Okay, so now it seems to be not so perfect again. Okay, because the x-axis line and also the y-axis line are missing. So you can also try to draw the line if you want. Okay. But because now I want to estimate the median Q1 and Q3, so I can also try to have some small boxes, something like this. You can go to here, okay, to select the one that with these some lines for you to do some estimation later on. I'll choose this one. I'll choose this layout because this layout provides the extra lines for you to do estimation for the x and also the y value later on. So I'll choose this one. All right. Okay, so now is I want to add also the x and y axis. So I go to choose this one, the format axis. To choose the line. I choose this one, fill and the line. Okay, I choose line, solid line. Make sure that it's black color better, easy to see. Okay, so for the y axis also the same. You highlight this, select this. All right, so since this format axis dialog box already given to you, so you can just go to choose this one and then choose solid line and make sure that it's black color. Okay, so once confirmed, just leave from the format axis dialog box. Okay, so it's already here. All right, so now if you want to do estimation for the Q1 median and also Q3 you can do so using the agile curve. So how? Okay, I already drawn. Okay, in fact, okay, let's say median. Median we know that is middle, right? Middle, that means is at the term of 50. Term of 50. So what can I do is, okay, I try to increase the size so that you can see. Okay, so what can you do is you draw a straight line, a horizontal straight line from T50. 40 we know that is here. This is 40%. This is 60%. So 50% should be in between these 2 points, right? So it should be here, middle. So you can try to draw a straight line, horizontal line. Okay, from this point until touching the agile curve. Okay, then from this point, draw a vertical straight line until touching the x-axis. So the median value is here, this point. Okay, you can roughly estimate the value is about 64. Not so accurate, but you can estimate. Formula is still better. Okay, the formula that you learned this morning is still better than using the agile curve. Okay. So some students may ask, then how about if we want to estimate the Q number 3, let's say Q3, also the same. Okay, you draw a vertical line, the horizontal line until from the 75th percentile. Okay, this is 70 is here, so 75th percentile should be somewhere here. All right. You draw a horizontal line. Okay, so this point is the Q3 term of Q3. Okay, which is T75. All right. Then for this point, you draw a vertical line from this point until touching the x-axis somewhere here. Okay. Okay. Then identify or estimate your Q3 value, which is this point. Seems to be is greater than 70 but less than 80 lah. All right. Maybe 70 plus 72, something like that, right? 72, about that, yeah. Depends on the way you draw the graph as well. Yeah? That's why agile curve may not be really, not accurately estimate the Q1, Q2, and Q3. Better use formula. Okay, that is my suggestion. Okay, it's nearly 12 o'clock. All right. Okay, so tomorrow is okay. Tomorrow we still can do revision on what we have learned. I already attached the summary on what we have learned. in the past 2 weeks on the numerical measurement as well. So tomorrow we can go through. And I think also we got one student asking about exercise 1.7. Tomorrow also we'll go through exercise 1.7 question on how to transfer the ungrouped data into group data, and also how to do the calculation for mean, mode, median, and also how to draw the agile curve and also histogram. Tomorrow we can discuss again. Okay. And also one student also asking how to submit your project 1 assignment. Okay, project 1 assignment I already created the submission place for you to submit. So tomorrow I'm going to demonstrate to you also, okay, how the steps involved to submit the project 1 as well. Tomorrow holiday. Okay, let me see. Is that holiday tomorrow? Oh, is that a holiday tomorrow? Okay, let me see. Tomorrow is 19. Let me see. Is that a holiday? Okay. 19 is that holiday? Yeah, it's a holiday. Yeah. So no class. Yeah, suppose no class then. Thank you for reminding. Yeah, no class. Yeah, 19 is the Prophet Muhammad birthday. Yeah, thank you for reminding. So if that's the case, okay, maybe we can discuss on Friday. Okay, Friday we can discuss again. Thank you for mentioning about tomorrow is a public holiday, correct? Yeah. And then I had to put announcement. Okay, it's okay. Then that means we have few more days, okay, to do your exercise or practice, right? Before we discuss on Friday. Yeah. Okay. Okay. I'll make announcement later on. Yeah. Tomorrow no class. It's a public holiday. I did not notice. Yeah. Okay. Then Friday we can discuss. Okay. Friday we'll discuss on how to submit the assignment. Any other questions? Besides public holiday? Yeah. Okay, this recording, okay, today I'm going to pause also on the Canvas later on. Okay, let me stop recording now, otherwise it's too long. Because if